Yeah. Yeah, a floral design on the floor is made using triangular tiles of dimensions 9 centimeter, 28 centimeters, and 35 centimeters. If 16 tiles are used to make the floral design, find the cost of polishing it at 2 rupees 50 paise per centimeter square. All right. So what is this floral design? It's a flower-like design. So usually, in villages, the in the hall, the middlemost tile, or maybe at regular intervals, we see tiles giving the shape of a flower, like this. Two triangular, two triangular tiles, two triangular tiles are placed in such a way that they form the petal of a flower. I'll just try to do it. May not be very neat. Okay, so this is a petal of a flower, similarly like this. It's not going to be very good, but such designs are common, no, in villages. Your grandmother's house, like this. Two triangular tiles will be used to give the shape of a petal of a flower. Can you see that? That's a floral design, a flower-like design. On the floor, is made using tiles. This flower-like design, this floral design, is made using tiles, using triangular tiles. Two triangular tiles put together makes a petal. So if you want your flower to have 16 petals, 16 petals, one petal, two tiles. So 16 petals, 16 into 2, 32 tiles you will need. So these petals are made using triangular tiles. For one petal, you will need two tiles, right? Yes. So that's what it is. A floral design on the floor is made using triangular tiles of dimensions given to you. The sides of the triangular tiles are given to you. If 16 tiles are used to make the design, so totally 16 tiles are used. You don't do 16 to 232. If 16 tiles are used to make the design, they have used 16 tiles, 16 triangular tiles to make the design. That's it. Find the cost of polishing it at rupees 250 per centimeter square. Very simple, no? We need to find the area of one triangular tile using Heron's formula. Find the area of one triangular tile using Heron's formula. You know all the three sides, 9, 28, 35. Heron's formula. Multiply that by 16 to get the area of 16 tiles. And multiply that with the rate, 2 rupees 50 paise, to find the total cost. I'm just presenting that. And you get root 6. And so the value of root 6 is provided in the question. Root 6 is 2.45. 2.45, not one. That one thing is like polishing or a polishing of the P. No. See the question. Okay, it's 2.45. All right. Okay. So you just go through the answer. I'm not explaining anything more than this. See here. Area of one tile, 36 root 6. Root 6 value is 2.45 given in the question. So this is the area of one tile. 88.2 centimeters square is area of one tile. Correct? Yes. 16 tiles are used. One tile's area we have found using Heron's formula. Why did we choose to find the area using Heron's formula? Because we only know the length of the three sides. So we can find the area only using Heron's formula. And we found the area of one tile. So area of 16 tiles will be 16 into 88.2. So 1411.2 centimeters square. The cost of polishing will be area into rate. Correct? Oh, that's about the second one. The next one is Again, this very question we have done in the class. Yeah. If each side of an equilateral triangle is tripled, find the increased percent of area of the triangle. So let the original area. It's an equilateral triangle. It's an equilateral triangle. So the area of the triangle is √3/4 into a square. Now we'll just call that delta. We'll call this √3/4 a square as delta. Say means let. I've written say, right? Meaning let's say, don't we say, let's say it is equal to delta. So like that, say. Okay. The area of the equilateral triangle is √3/4 a square. Okay, and we'll call this expression delta. √3/4 a square as delta. Okay. Now the new area of the triangle, the sides are triple, right? So the new side is 3a. So √3/4 into 3a the whole square, not 3a square, 3a the whole square, side square, √3/4 into 3a the whole square. This is the side, new side 3a, the whole square. So √3/4 into 3a into 3a, 9a square. All right. Now you just write this so that you can see √3/4 a square. So see here, can you see √3/4 and a square here? So put that in the bracket and write this 9 outside. Just rearrange so that you can see √3/4 a square because that is delta. So you're trying to write like how many times delta? How many times delta? So bring the 9 here and then √3/4 a square in the bracket. So there's nothing but 9 delta. See, children, the formula is √3/4 into side square. What's the new side? 3a. 3a the whole square. 3a into 3a is 9a square. Put the 9 outside and then √3/4 a square in the bracket. And so it's 9 delta because √3/4 a square is delta. So 9 delta. Okay, so when the side is a units, the area is delta. When the side is 3a units, the area is 9 delta. Original side delta. When the side is tripled, when each side is tripled, the new area is 9 delta, 9 times delta. So what's the increase? 9 delta minus delta. 8 delta is the increase. An increase percent? Increase by original into 100. Increase is 8 delta, by original is delta into 100. Delta and delta gets cancelled. Delta and delta gets cancelled. 8 into 100, 800%. All right? Yeah. That's the answer for the third question. Okay. Yeah. So this is find the area of an isosceles triangle. The question is find the area of an isosceles triangle having base x centimeters and one side y centimeters. Okay. Base is x centimeters. And one side, isosceles triangle, right? So if one side is y, the other side is also y. Base is not any of the equal sides. You cannot say, we'll take two sides as x and one side as y. You don't have that option. You cannot take two sides as x and one side as y. Why? Because they've given base as x. Base is not any of the equal sides. Base is that side which is not any of the equal sides. So one side is y, so the other side is also y, and the base is x. Okay. Now we need to find the area using Heron's formula. To see the calculation of semi-perimeter. Just check your answer. Have you all tried this one? Yes. You have tried. So just check your answer. See where you've. If you're right, good. Otherwise, you can ask me where you went wrong. X is the base plus y plus y. Sorry, 2y/2 because y plus y, 2y/2. Now you cannot cancel this 2 and 2. 2 cancel from you. See, whenever there is, a plus or a minus sign in the middle, see. See, if it is x into 2y, by 2. Then you can cancel. But when it's x plus 2y by 2, the meaning is it is x plus 2y is like it's 1 unit. X plus 2y is 1 unit. So you cannot disturb it by cancelling like this. See, that's why when we have 2x plus 4 by 2, we take out 2 common and then x plus 2 by 2. Now it's multiplication. It is 2 into x plus 2. So you can cancel this 2 and 2, but not this 2 and 2 because this is x plus 2. When the sign is plus or minus in the middle, then you cannot cancel. You cannot disturb that. That's 1 unit. Ouch. Okay. All right, so S, this is S. Into, can you see S minus X, A. Then again S minus Y. Again S minus Y. Because X, Y, Y are the signs. Correct? Okay. So this comes as it is. Now take the common denominator. 2 is a common denominator everywhere. So it will become 2x, 2y, 2y. That's what you see here. See, x plus 2y minus 2x by 2. LCM is there. Okay. The LCM. X plus 2y minus 2x by 2. Then LCM in the next step. In the x minus 2x is minus x. X minus 2x is minus x. It's very faint, it's very light here, but this is 2y. This one will come down as it is. This is 2y. 2y minus, I made a mistake in writing, so I've just used a whitener and corrected it. Okay, so 2y plus x minus 2x is minus x by 2, plus 2y minus 2y cancels. So we have x by 2, and here plus 2y minus 2y, so we have x by 2. கீழே வந்து எவ்வளவு எக்ஸ் 2 இருக்கு 1 2 3 4 2 இருக்கு டினாமினேட்டர்ல சோ 2 2 வெளியில வந்துரும் டினாமினேட்டர்ல 4 2 இருக்கா 2 2 வெளியில வந்துரும் அப்புறம் நியூமரேட்டர்ல வந்து 2 x இருக்கு ஒரு x வெளியில வரும் அப்புறம் வேற எதுவும் பண்ண முடியும் you cannot do anything else I'll just work this part alone see under the square root we have okay, we have x plus 2y by 2 into 2y minus x by 2 into x by 2 into x by 2. இப்போ இங்க ரெண்டு இப்படி கூட பண்ணலாம் ரெண்டு x by 2 இருக்கா ஒரு x by 2 வெளியில வந்துரும் அப்புறம் இங்க டினாமினேட்டர்ல ரெண்டு 2 இருக்குல்ல ஒரு 2 வெளியில வரும் ஒரு 2 டினாமினேட்டர்ல வெளியில வரும் அப்ப இங்க மேல 1 போட்டுக்கணும் what remains under the square root x plus 2y and 2y minus x this remains so you can treat this as in the x plus 2y வந்து நீங்க 2y plus x ன்னு மாத்தி எழுதிக்கலாம் we'll do that again x by 2 ரெண்டு இருக்கு ஸ்கொயர் ரூட் அடியில சோ ஒரு x by 2 வெளியில வந்துரும் அதுக்கு அப்புறம் டினாமினேட்டர்ல இங்க ரெண்டு 2 இருக்கு அப்ப ஒரு 2 வெளியில வருமா ஆனா டினாமினேட்டர்ல எழுதணும் அப்ப 1 by 2 ன்னு எழுதணும் அது so x by 2 into 1 by 2 comes out of the square root. Now what remains under the square root? 2y minus x and 2y plus x. X plus 2y and 2y plus x in maathirunga. So 2y minus x into 2y plus x remains under the square root. So that can be treated as a plus b into a minus b, which is a squared minus b squared. So it's 4y squared minus x squared. And here when you multiply 1 into x is x by 4. So the area of the isosceles triangle is x by 4 into square root of 4 by square minus x square. All right? Okay. The next question is, I think this is a repeat. Yeah, this is repeated. Yeah. Is it this one? The sides of a triangle, yeah, we're discussing the answer to this question. The sides of a triangle, the sides of triangle ABC taken in order are 11 centimeters, 15 centimeters, and 16 centimeters. You all have the question. Find the length of the shortest altitude. Okay, we have to find area first. We have to first find area. Use Heron's formula and find area 30 root 7. Next, you need to find the length of the shortest altitude. Shortest altitude. You should find the altitude. Should find the altitude. அப்ப எதை பேஸா எடுக்கணும்? Shortest altitude na longest base எடுக்கணும். Longest side. Yeah. We have to find the length of the shortest altitude. The shortest altitude will fall on the longest side. So take the longest side as the base and find the corresponding altitude. That will be the shortest altitude. So see here, area is equal to 30 root 7. After that, first, area is equal to 30 root 7. Area na half base into height. Half base into height is equal to 30 root 7. So height தான் கண்டுபிடிக்கணும். H கண்டுபிடிக்கணும். எது பேஸா எடுக்கிறது? Which is the longest side? 11, 15, 16. எது longest side? 16. 16 பேஸா எடுக்கணும். நீங்க longest side பேஸா எடுத்தீங்கன்னா அப்ப shortest altitude கிடைக்கும். இதுதான். Half into 16 to H is equal to 30 root 7 and cancel and transpose.
Altitude, we have to take the shortest side.
Yeah, longest altitude means shortest base. Shortest altitude, longest base. Value of?
Just 1.62.
If you're not given the value of root 7 in the question, you can leave the answer like this. What's the value of root 7? Not 0.6, 2.64. Yeah, so it will be 15 by 4 into 2.64.
Okay.
9.9. 9.9. 2.64 is the value. But you can leave it like this because if you're not given the value of root 7, you can leave it. See, in one question earlier, the value of root 6 was given to you. Then use that value. எந்த வேல்யூஸ் நீங்களா போடணும்னா root 2, root 3 மட்டும்தான். root 2 ஏன்னா நம்ம ரொம்ப often யூஸ் பண்றோம். root 2 is 1.414. root 2 is, the value of root 2 is 1.414. And the value of root 3 is 1.732. ஏன்னா இத root 3 வந்து நம்ம ஈக்குவலன்ட் ட்ரையாங்கிள் யூஸ் பண்ணுவோம்ல root 3 by 4 a square 1.732. இந்த ரெண்டு வேல்யூஸ் தவிர வேற எல்லாம் கொடுத்தாதான் நீங்க சப்ஸ்டிட்யூட் பண்ணுவோம். இல்ல அப்படியே விட்டுறலாம், ரூட்லயே விட்டுறலாம். You don't have to find the value of root 7. You can leave the answer like this. Okay. If the value of root 7 is given in the question, use it. Otherwise, just leave it like this. In one question earlier, we were given the value of root 6. So we applied it. Otherwise, you can just leave it like that. Okay. So that's about this answer. This was a very simple question. We have one more to discuss, right? Okay. Yeah. No, nothing. Just help yourself.
Or can you explain the area part?
Okay, we'll do it from the beginning. So what is given? Perimeter is 42. Perimeter is 42 and its base is 3 by 2 times each of the equal sides. So if you call the equal sides as x, base is 3 by 2 into x, because 3 by 2 times, times means multiplication. So 3 by 2 times each of the equal sides. So 3 by 2 x. So let the equal side be x. So the base will be, it's given very clearly. Base is 3 by 2 times each of the equal sides. So base is equal to 3 by 2 into x. 3 by 2x or 3x by 2. So what are the sides? X, 3x by 2. Equal sides, x. Equal sides, x, isosceles, x, and the base is 3 by 2 times x. So 3 by 3x by 2. Now what's given? Perimeter is 42. Don't use Heron's formula now. Perimeter is 42. That means what? The sum of the three sides is 42. No, at this point, don't use Heron's formula, I'm saying. How do you continue working? So perimeter is 42. So that means x plus 3x by 2 is equal to 42. Then take the LCM. Take the LCM. So 2 is a common denominator. Like it's 1 by 1. So into 2, into 2. So into 2, into 2. Is this your doubt? Okay, fine. So then you get 7x by 2 is equal to 42. X is equal to 7 by 2 on the other side, 2 by 7. So x is 12. X is 12. So what is the base? 3 by 2 into 12. 18. On cancelling, you get 18. On simplifying, you get 18. So now we have the sides 12, 12, 18. The question is to find the area of the triangle. So you have the sides now. So find the area. 27 root 7, you can start there. These were some very basic questions from Heron's formula. You need to practice. If you feel I'm able to understand, if this is your plight, that no, I understand in the class, but when I am given questions to work, I'm not able to work. Then it's practice. That's because you're not practicing by yourself at home. You're only doing assisted working. So in the class, it is assisted working. No, the question is explained, answer is explained, and you work it. You're not on your own. You're assisted every time. So that way you feel comfortable. But when you're left all by yourself, you're given a set of questions, you're left all by yourself. You have to read the question, understand the question, and then understand how to work. And you're not able to do it. That is because you're not visiting the questions again, the questions and the answers again. You need to visit them. And when you do that, only you'll believe that it's because you're not practicing, you're not able to remember. Otherwise, you'll only think, you will not believe my words. நீங்க இதே சம்ஸை நீங்க திருப்பி வீட்ல பிராக்டிஸ் பண்ணாக்க கண்டிப்பா ஞாபகம் இருக்கும். நெக்ஸ்ட் டைம் இந்த மாதிரி ஒரு கொஸ்டின் கொடுத்தாக்க உங்களுக்கு எப்படி பண்ணணும்னு தெரியும். நீங்க பிராக்டிஸே பண்ணலன்னா கண்டிப்பா உங்களுக்கு கஷ்டம் தான் தோணும். யூ வில் ஃபீல் இட்ஸ் டிஃபிகல்ட். Well, it's not difficult. It's because we don't revise at home. புரிஞ்சுக்கிறோம், மறந்து போயிடுறோம். புரிஞ்சுக்கிறோம், மறந்து போயிடுறோம். மறந்து போக விடக்கூடாது. நீங்க திருப்பி அதை ஒர்க் பண்ணிட்டீங்கன்னா ரீடைன் பண்ணிக்கலாம். Okay, so today I'm going to give the introduction to circles. How many of you have learned this chapter in school? Going on.
Not started.
Not started.
Not started.
Finished. Online children, Harsha, Haridarshan, Sanjay, Shriya, and Yarni. How many of you have learned circles in school?
Ma'am, I have not learned.
Raise your hand if you have seen. Yeah. Just raise your hand if you have learned this chapter in school. Okay. All right, yes. Sanjay and Shriya have not. Okay. Okay. I'm just going to do the numerical part of circles first because The rest of it, okay, let me not talk beyond that. I'll just do the numerical portions first, okay? So I'll give you the introduction necessary to crack the numerical questions. Yeah. Okay. So the basic terms you need to, understand with respect to circles are sector. I think for now sector is enough, but I'll also tell you what a segment is. Okay. Sector and segment. Now, circle, center, radius, arc. A region of the circle bounded by two radii and one arc is called a sector. A sector is a region of the circle bounded by two radii and one arc. Radii, arc. This is a sector. Now, if this sector angle is, because the total angle around the point is 360 degrees, if this sector angle is less than 360 by 2 is what? 180, right? If the sector angle is less than 180, now say here the sector angle is some 70 degrees. This one is called a minor sector. Minor sector. So what will be the angle here? 360 minus 70, 290 degrees. Now this is the major sector. Now this one is a sector because you can see radii, and an arc. And see 290 degrees. So how do you identify a sector? Just see if it satisfies the definition. What is the definition? Region of a circle bounded by two radii and one arc. It need not look like this always. Don't look for a piece like this. See if the closed figure satisfies the definition. In the figure, if you can see two radii and one arc, then it's a sector. So here see two radii, center, this is radius, and this is the arc. Now this arc is called the major arc. And this arc here is called the minor arc. The arc attached to the minor sector is the minor arc. The arc attached to the major sector is the major arc. And what are arcs? They're a part of the circumference of the circle. This is a circle, right? So from here to here is minor arc. It's a part of the circumference of the circle. The rest of it is the major arc. So in the major sector, the sector angle will be more than 180 degrees. In the major sector, the sector angle will be more than 180 degrees. If it's less than 180, minor sector. More than 180, major sector. Equal to 180, it's a semicircle. Because a semicircle is also a sector. A semicircle is also a sector because it satisfies the definition. A radius, arc. A semicircle is a sector. A semicircular region is a sector because it's bounded by two radii and an arc. And here the angle is equal to 180 degrees. Special name is semicircular region. It's also a sector because it satisfies the definition. Radius, and arc. So if the sector angle is equal to 180 degrees, it's a semicircular region. If the sector angle is less than 180, minor sector, more than 180, major sector. So major sector looks like something like this. A minor sector looks like this. That's about a sector. A segment of a circle is a region bounded by a chord and an arc. The region of the circle bounded by a chord and an arc. Chord, arc. Segment. Now, if the segment contains the center of the circle, it's the major segment. If it has a center, it's a major segment. If it does not have the center, it's a minor segment. See, circle, the center is here. See, this one is a major segment because it satisfies the definition. Chord and an arc. What's the definition of a segment? Part of a circle bounded by chord and an arc. Chord and an arc. So you can see chord and an arc. So a little chord and an arc. Now this one contains the center. This one does not contain the center. So this one is the major segment. This one is a minor segment. So this is the minor arc. This is the major arc. Now what if the center lies on the chord? Okay, the center. Okay, so we were talking about the cases where the center lies in either of the two segments. What if it lies on the chord? So circle. That means the chord is a diameter. If the center lies on the chord, then that chord is the diameter. The center lies on the chord. It's a diameter. So, this one and this one are segments because they satisfy the definition. Chord and an arc. Chord and an arc. Now the center lies on the chord. So you cannot say this is minor, this is major, or this is minor, this is major. So each one is called the semicircular region. Semicircular region. A semicircular region is both a segment and a sector because it satisfies both the definitions. A semicircular region is both a segment and a sector. A semicircular region is both a sector and a segment because it satisfies both the definitions. Now, when you take the definition of a sector, 2 radii and 1 arc. 2 radii and 1 arc. It's a sector. Definition of a segment, chord and an arc. This is the diameter, it's a chord and an arc. Yes. So a semicircular region is, you can call it a sector or a segment because it satisfies both the definitions. That is a special name, semicircular region. Now coming to the properties or some theorems related to some theorems which we will be using in solving numerical questions. Now, I'll tell you a few as and when we encounter them in some questions. Now, the most important one is consider an arc AB on the circle. Consider this arc AB on the circle. O is the center. Join OA
And
OB. Now, this is the angle made by the arc AB at the center. This is the angle made by arc AB at the center. Now, take a different point of the circumference. Okay, now supposing I take a point D on the circumference, I take a point E on the circumference. Let me say this angle is 60 degrees. Now, how do we explain this? Arc AB subtends. Yeah, makes angle 60 degrees at the center. Now the same arc AB makes angle ADB on the circumference. Same arc AB. See, I'm joining A to D, B to D. Look at the figure. I joined A to D and B to D. Which is the arc? AB is the arc. Which is the point on the circumference? D. The arc is AB, right? The arc is AB, okay. And there's a point D on the circumference. What did we do? We joined A to D and B to D. That is the ends of the arc to the point D on the circumference. So what is this angle? This angle is made by arc AB at D. Arc AB at D. Similarly, try to join A to E. Oh God. I'll take E somewhere else so that it doesn't look congested. Join A, the arc is AB, join A to E and B to E. So this angle is the angle made by the same arc AB at a different point E on the circumference. So now we have three different angles made by the same arc AB. This one arc AB, it makes AOB at the center and it makes ADB on the circumference at the point D, and it makes angle AEB on the circumference at the point E. Now coming to the relation between these angles. The angle of the center, that is angle AOB, is twice the angle on the circumference made by the same arc. We're talking about that one arc AB, right? AOB is equal to twice angle ADB. The angle of the center is double the angle on the circumference made by the same arc. If an arc makes an angle at the center, that angle is double the angle made by the same arc at a different point on the circumference of the circle. So that means the angle of the center is always more, okay? The angle on the circumference will be less. So see, what is angle AOB? 60 degrees is equal to twice angle ADB. So what is ADB? ADB is equal to 60 by 2, 30 degrees. So ADB is 30 degrees. What about this one? Angle AOB is equal to twice angle AEB. Why? Because AOB, see, the first thing is AOB and AEB are two angles made by the same arc AB. And you can also make out from the names AOB, AEB. AB is the arc, O is the center, AB is the arc, E is the point of the circumference. So from the name itself, you can make out if the angles are made by the same arc or different arcs. You can see from the name AOB. Okay, AOB is the angle made by arc AB at the point O, that is at the center. And AEB is the angle made by the same arc AB at the point E on the circumference. Now, which angle is more? Center will be more. Circumference will be half of that. So AOB, so here angle AOB is equal to twice angle AEB. Yeah, how much is the AOB? 60 is equal to twice angle. So how much is the angle AEB? 60 by 2, 30 degrees. But we got ADB also 30, no? ADB is 30, AEB is 30. Okay, so this is about the second theorem. So the first one is the angle made by an arc at the center is double the angle made by the same arc at a point on the remaining part of the circle. I'll tell you what remaining part of the circle is. That's what we just saw. The other one is angles in the same segment of a circle are equal. Angles in the same segment of the circle are equal. See here, now, this is one segment. No, this is the major segment, right? Yeah. Now, if you have angles in the same segment, now let me like this is an angle in this major segment. This is an angle in the major segment. This is an angle in the major segment. These angles are equal. Because they're all made by the same arc. See, because they're all made by the same arc at three different points on the circumference. So imagine the same arc makes an angle at the center, and supposing this is 70. So this will be 35, no? This also will be 35, this also will be 35. Why? Because this one arc is making 70 at the center, and it's making angles at three different points on the circumference. And we know that those angles will be half of 70. So each one of it will be 35. So that means all these angles are equal, right? So that is the theorem. Angles in the same segment of a circle are equal. Circle, center. If this angle is, say, 50 degrees, same arc What are the angles you see here? Angle AOB and angle ACB. You can very clearly see that it's made by the same arc AB. Both the angles are made by the same arc AB. One is at the center, one is on the circumference. So if the center is 50 degrees, circumference is 25 degrees. This is one of it. Okay. The other one is the other one is like if this angle is some 45 degrees, this also will be 45. 45 because if you connect these 2 points, all these angles are in the same segment. All these angles are above the chord. They can be above or below the chord. All must be above or all must be below the chord. Now you can see that all these 3 angles are above the chord, right? So they're in the same segment. And it should not be half the way like this. It should not be like one angle is not like this. These angles are not equal. They should touch. It should be, the angles must be formed on the circle. Yeah. No, there's nothing about this figure. You cannot say anything about these angles. So angles in the so we say angles in the same segment of a circle are equal. Same segment because see, with respect to this chord, this is the major segment. Above the chord here is the major segment, and all the angles are in the same segment, the major segment. So they are those angles are equal. The other theorem is that angle in a semicircle is a right angle. Angle in a semicircle is a right angle. Now, this is the diameter. How much is the angle here? 180 degrees. Diameter. So this angle is 180. Okay. So it's like this arc makes this angle at the center. You should join the, I told you, now there's a center O. Now let's say that this AB is the arc, which is a semicircle. AB is an arc which is a semicircle. I told you should join the ends of the arc to the center. So join the ends of the arc, A to the center, B to the center. So this is the angle made by this arc at the center, and that will be 180 degrees because it's the diameter. Now the same arc, take a point on the circumference, the same arc, join A to C, B to C. The same arc makes this angle on the circumference. So we've learned by the theorem, no, that this will be half, so it's 90 degrees. Angle in a semicircle is a right angle because this is the diameter. Angle in a semicircle is a right angle. Circle, semicircle. Take any point. Take any point. So AB is the diameter. C, join A to C, B to C. This is 90 degrees. Take any point. If this is the diameter, that means the center lies on it. Take a point D, join A to D, B to D. This angle is 90. Take another point. Join A to E, B to E. This is 90 degrees. That's because this is 180. So half of it is 90. By the theorem, the angle made by an arc at the center is double. This one is double the angle made on the circumference. So how do you name, see what's the angle at the center? AOB, 180. Name the other angles. ACB, ADB, AEB. These are the other angles. AOB is at the center. ACB, ADB, AEB are the other angles. You can very well make out that all these angles are made by the same arc AB, AB, AB. But this angle is at the center O, while these angles are made on the circumference at 3 different points C, D, and E. Half, 90. So center angle is double the circumference angle is 1. Angles in the same segment of a circle are equal. Angle in a semicircle is a right angle. Okay, the fourth one is, and always remember that in a figure like this, if supposing this angle is 30 degrees, for example, now this one is always an isosceles triangle because OA radius, OB radius. This triangle is always isosceles because OA, OB radius, no? So if these two sides are equal, these two angles are equal. This also is 30 degrees. So that means this is 120. So remember the isosceles triangle property in this triangle because OA, OB radius. Remember this, okay? And I was telling you, no, I think I will start. Okay, yeah. So 3. This is the fourth one. Now the fifth one. In a cyclic quadrilateral, opposite angles are supplementary. In a cyclic quadrilateral, opposite angles are supplementary. Now, what is a cyclic quadrilateral? Quadrilateral? Okay, correct. So, is this a cyclic quadrilateral?
No.
Why?
The parts of the circle.
Yeah,
And the four vertices should touch a circle, ma'am.
correct. So, say like we take 4 points A, B, C, and D like this. So, when you join A, B, so now this one is a cyclic quadrilateral. Because in a cyclic quadrilateral, yeah. So that means, okay, 1 minute. Now, can I say that there is no circle, no? Can this be a cyclic quadrilateral? There is no circle here. Can it be a cyclic quadrilateral? It can be. It's not that you should see the circle drawn. You can draw a circle passing through A, B, C, D. It's not that a cyclic quadrilateral should always be be presented inside a circle. See, if I give you a figure like this, ABCD, and I say that ABCD is a cyclic quadrilateral, you should believe me. You must believe me. I'm saying like ABCD is a cyclic quadrilateral. That means there is a circle. You can draw a circle passing through ABC and D. You don't see that circle here, but you can draw a circle passing through ABC and D. I'm not clear? Okay, let me make it now. Is this a cyclic quadrilateral?
Yes, please.
This is a cyclic quadrilateral, right? Okay. It's a cyclic.
Yes.
It's a cyclic. You can draw a circle passing through ABCD, right? ஆனா அது இல்ல இங்க அவ்வளவுதான். அதுதான் நான் சொல்ல வந்தேன். That's not a cycle. Then the circle is an in-circle. That's not a cyclic quadrilateral.
Cyclic
We are talking about a cyclic quadrilateral. What do you want to know? Okay, yeah.
Miss, can we draw a cyclic quadrilateral exceeding the surface of a circle, Miss? Exceeding the surface of a circle.
That's not a cyclic quadrilateral.
I showed it. Can we draw a circle with point? The only point as the circumference of the circle.
No, your question is that a cyclic quadrilateral, is it? No. If it's a cyclic quadrilateral, then all the 4 points must lie on the circle. It's a quadrilateral. It's not a cyclic quadrilateral.
This one, Miss, I'm asking that out. Can we draw the
No, that's not a cyclic quadrilateral. That's just a diagram, that's all.
Okay.
There's no special name to that diagram. Okay, so if I say ABCD is a cyclic quadrilateral, you should believe, meaning it's not that, no, there is no circle, then how can it be a cyclic quadrilateral? It is a cyclic quadrilateral. That means you can draw a circle passing through A, B, C, and D. Now coming to the property. In a cyclic quadrilateral, opposite angles are supplementary. The sum of this angle and this angle will be 180. So if this is 70 degrees, this is 110 degrees. And say this is like 100 degrees, this will be 80 degrees. In a cyclic quadrilateral, opposite angles are supplementary. That's one property. Then the other property is in a cyclic quadrilateral. Supposing you produce one side. You produce one side. Then an exterior angle is formed, right? When you produce one side, when is an exterior angle formed? For any polygon, when is an exterior angle formed? When you extend one of the sides. So when you produce this side, exterior angle is formed. And this exterior angle in a cyclic quadrilateral is equal to its interior opposite angle. See, how many interior angles are there? 1, 2, 3, 4 interior angles. This one is the immediate interior angle for this exterior angle. This one is the immediate interior angle for this exterior angle. So this exterior angle is equal to its interior. So for this exterior angle, this is its interior angle, interior opposite angle. And you can see that here. This 89 100 linear pair. Can you see? This 100 na inga 100 is parunga.
Exterior angle made by the exterior angle made by the is equal to the opposite side.
Exterior angle is equal to its interior opposite angle. See here, produce this side. Produce this side. This 70. Can you see 70 here? Yeah, so exterior angle is equal to its interior opposite angle. Immediate interior opposite angle. Produce this side. This 110. This exterior angle 110. This immediate interior angle, see the opposite angle 110. So this is a property. Exterior angle is equal to, in a cyclic quadrilateral, not in every other quadrilateral, in a cyclic quadrilateral, exterior angle is equal to its interior opposite angle. I think yes, we are good to take up some numerical situations. Yeah. Let's just write out everything. Take down this in your book, children. Take down this, all of you. Yeah, circles. Just take down this figure. I think you don't write and just don't write anything. Meaning, I'm not giving you statements, but from this you can make out. If that is x, this is 2x. Or maybe I'll just write it like this.
We want to make the theorem different.
I've just marked those angles, very equal. Is that okay? Yeah. Yeah. Try this one. No, don't take, no, just answer it orally. Read the question, work it in your mind and tell me the answer. Angle BOC is? Correct. BOC is 96, correct. OBC?
No, OBC is equal to 64.
How? Look at that, 48/2.
Ma'am, OBC also 96 degree.
No,
No, it's OBC 48 degrees.
no. Okay. So BAC is 48. This is 48. All right. So this one should be 96. Correct. Now I told you that OBC is an isosceles triangle. So these two sides are equal because radius, which means these two angles are equal. So 96 plus x is equal to 180. You can call each angle x. 96 plus x is 180. Now tell me what's the value of x? So x is OBC. X is OBC.
No, 42. No, 42. 60. No, 42.
How much?
42. 42.
Correct.
Can we share the image?
No, you understand? No, I'll share the images. We'll try to answer many questions. You can finish this as homework. Understood, right? So what I have written, I have not taken x and all that. So you can see, so these two angles are equal. OBC is equal to OCB, correct? OBC is equal to OCB. So using angles and property, this angle BOC plus this angle is 180. But since these two angles are equal, I've written OCB also as OBC. OCB also as OBC.
Yeah. I did 96 minus 180 and I got 84. Can we not stop at 84? 180. Because
Then you only have two angles in the triangle. What about the third one? Okay. You can make it more comfortable for you, like you can mark this as 96. You draw the figure in your book and you can also do it like this. You can take these angles x and 96 plus x is equal to 180. You can change the presentation style. Okay. Okay. Try this one. Now, is OABC a cyclic quadrilateral?
Ma'am, APC 240 degree, ma'am.
Is OABC a cyclic quadrilateral?
No, because the point O is not touching the circle. It's not touching the circle.
OABC is not a cyclic quadrilateral because O does not lie on the circle. Is PABC a cyclic quadrilateral? Yeah, because PABC.
Also points touch the circle.
PABC is like this. PABC. Yeah, this is cyclic. Don't get confused with these lines which are inside. Okay. Fine. What's APC? APC.
60 plus 2.
What is the measure of APC?
60. Ma'am, ABC.
16.
Ma'am, ABC is 30 degrees. ABC is
No. APC is 60 because what's the property?
opposite side.
What is angle? What is angle? Angle AOC is made by AC at the center. The same angle makes APC on the circumference. AOC, APC. See here. This is the arc AC. This is the arc AC. AC makes AOC at the center. The same arc AC makes APC on the circumference. APC on the circumference. See here. AC is the arc. AC is the arc. AC makes, see, what did I say? Join A to O, C to O. This is the angle made by the arc AC at the center. Now the same arc AC, the point is P on the circumference. Join join A to P, C to P. And this is the angle made by the same arc AC at the point P on the circumference. So this angle is double this angle. So there will be 60 degrees. This only will be more. Center is more. So then this cannot be 240, no? 60. It's half of it. So how do you present that? Angle AOC. You must write the relation between the two angles. Angle AOC. See, if you want, you can write and directly angle APC is equal to half of angle AOC. You're right. APC is half of angle AOC. So half of 120 degrees, which is 60 degrees. Or else you can write angle AOC is 2 times angle APC. AOC is 2 times APC. So how much is AOC? 120 is equal to 2 times APC. So angle APC is equal to 120 by 2, which is 60 degrees. Either ways you can go. APC is 60 degrees. Next, ABC. This one is 60. APC is 60. Next is ABC. How much is ABC? No. No.
240.
Calculation error. Oh, you're doubling 120, is it? Then you're wrong.
No, I think that was it's 120.
No. What's that?
120.
Why? They're equal, no?
Yes, miss.
Opposite.
Opposite time.
No.
By adding some property, we can add this. Yeah.
Property of cyclic quadrilateral. What? Identify the cyclic quadrilateral.
Opposite side. Opposite angles are supplementary.
APCB is a cyclic quadrilateral. Opposite angle is supplementary. Angle P plus angle B is equal to 180. Angle P plus angle B is equal to 180. So if angle P is 60, B is equal to 180 minus 60, 120. That's it. Okay. Yeah. This one.
First one's on me. First one is on me. This first one is 70, miss.
Name the name the angle of the center.
Miss BOD, miss.
BOD. Angle BOD. Name the angle of the circumference.
Angle BPD.
BPD. So can we see BD, BD? So these angles are made with the same arc BD. One is at O, one is at P. So whose double, like BOD is double, right? So how much is BPD then? 70.
70.
Correct? So BPD is 70.
And then
This is 70.
And DCQ is 70.
DCQ. DCQ.
Ma'am, DCQ 140 degree.
70.
Okay, you are saying this.
Ma'am, DCQ 140 degree.
How much DCQ is?
140 degree.
No.
This 110.
Yeah. How?
I was
No. It's not 110. Sorry.
70.
70. But how?
Because no, I just saw. Yeah. And opposite, see that is side body. So
Got
it's
it.
Ma'am, DCQ 40 degree.
No. So which is the cyclic quadrilateral here? P, P, G, C. This one is the cyclic quadrilateral, correct?
Yes, ma'am.
P, B, C, D. This is cyclic quadrilateral, correct?
Yes, ma'am.
Now the side BC. Which are the sides of the cyclic quadrilateral? PB, BC, CD, DP. Quadrilateral, 4 sides. Now this side BC is produced. So this exterior angle DCQ is formed. And the exterior angle is equal to its interior opposite angle, not this 140. This one. So it's 70. Yes or no?
Yes,
Not this one. This is not correct.
ma'am.
So first BOD, BPD. So this is 70. Then DCQ. So join DC. DCQ. It's about this angle. The cyclic quadrilateral is PBCD. This one is the cyclic quadrilateral. So this is the exterior angle because the side BC is produced. And so this angle is formed. This angle is equal to its interior opposite angle. 70. DCQ is equal to 70. Yeah, we'll wind up with this one.
This BDC is equal to
BDC. You need to find BDC. BDC. This is
BDC is 36.
70 degree.
That's 76. BDC is equal to 76. 52.
54 degree.
52.
no, online children are trying to answer. Yes. What's the answer?
Degree.
50?
2 degree 2.
How? No. 52 how?
I said 70.
70?
6.
180 minus 104. How? DCB, BCD, BDC, what's the idea? Name the angle 104 க்கு என்ன பேரு? HUC. இது BDC. எங்க ஒரே arc? Okay, 1 minute. Let's think backwards, okay? எந்த angle கண்டுபிடிக்கணும்? BDC தானே? அந்த ஆங்கிளுக்கு ரைம் வர மாதிரியே சென்டர்ல எந்த ஆங்கிள் பிடிசி னா பிஓசி பிஓசி எவ்வளோ 76 ஓகே so பிடிசி பிடிசி ஓட ரைம் மாறது வந்து பிஓசி தானே பிடிசி சர்க்கம்ஃபரன்ஸ்ல இருக்கு பிஓசி சென்டர்ல இருக்கு மேட் பை தி சேம் மார்க் பிசி so how much is BOC 180 minus 104 76 so this is 76 அப்ப சென்டர் தான் டபுள் அப்ப இது எவ்வளவு இருக்கும் 76 by 2 38 degrees okay this arc BC look at the board this arc BC makes BOC at the center yes or no the same arc BC makes BDC on the circumference இதோ நானா அது வரையறேன் புரியுதா இல்லையா இது பாருங்க நான் காமிக்கிறேன் நீங்க பாருங்க okay see here BC the arc okay serious O is the center of the circle join C to O B to O this is the arc made by BC at the center now the same arc BC this is the point D on the circumference join C to D ends of the arc C to D B to D this is the arc this is the angle made by the same arc BC at the point D on the circumference. Oh, you have to use the recording. Okay, so angle BOC and BDC, they are related. They're like siblings. Okay, they're related. BOC, BDC. They're made by the same arc. BOC, BDC. This is the elder one, this is the younger one. Because they're made by the same arc BC. BOC is the greater angle. So that's the elder sibling, this is the younger sibling. I said we'll answer this question backwards. BDC. BDC is this angle. So BDC and BOC, they're rhyming. So I said find BOC. How much is this angle BOC? 180 minus 104, 76 degree. Now this is 76. So this has to be half of 76, which is 38. Go home. Yeah, help yourself. I'll share the relevant images on WhatsApp and I'll give you all the instructions on WhatsApp as to what you have to do by the next class. All right. All right, children. So that's it for today's session. Thank you so much. You may need the call. Good night. Yes, you.